Okie dokie. So the oxidation number practice sheet. I tried to scan the questions and put them on here, and a couple of them worked, and a couple of the images wouldn't scan to me for whatever reason. So we're gonna have to kind of make do. So you'll see some of them I'll have up, others of them I won't. We'll just have to talk through them. Also, I am not writing on my smartboard, which I usually am doing. I'm actually writing using the computer, actually my laptop, so it's just not going to be as pretty as it usually is. I apologize for that as well. So let's go ahead with actually, you know what, I'm going to read to you the answers. So if you want to check your work, the answer to number 1 is E, number 2 is C, number 3 is C, number 4 is C, number 5 is C, number 6 is B, number 7 is D, number 8 is D, number 9 is C, and number 10 is E. Okay, so let's go ahead. We'll go to number 1. So it says, which of the following compounds includes an element with an oxidation number of a +5? These are time-consuming questions because really you just have to go through all of the options. I would always suggest not starting with A on a question like this that's going to require you to do process of elimination, because most likely they have picked C, D, or E as the answer because they're expecting you to start with A. So I would not start there. We do know the answer is E, so I'm going to go ahead and go through why E has that as its oxidation. Why there's an element in E that has an oxidation number of a +5. And then if you have any issues with any of the other ones, like if you got a +5 for any of the other elements in the other compounds, you can let me know and I can help you look at it individually. So the answer is the one that says NO3. Oh my goodness, this is going to be horrible. NO3 with a -1 charge. Okay, so remember that all these oxidation numbers are going to have to add up to equal 0. Oops. If it was a neutral compound, it would be 0. They have to add up to equal a -1, okay, because of that charge right here of a -1. So we'll go ahead and look at our rules. Again, you have to go through your rules and you have to be doing your rules in order. That's really, really important. So you're going to look for alkali metal, alkaline earth metal, aluminum first. After that, which we don't have any of those, then we look for hydrogen, which we don't have. Then we look for oxygen. So oxygen is going to be a -2 for its oxidation number. And again, I usually circle those so I don't forget that they're not really charges, they're oxidation numbers. There are 3 of those at a -2, so that's going to be a total of a -6 coming from the oxygen. Even if nitrogen was on our list, we would not use the list. We're going to determine what goes in this box mathematically. We know that this number plus the -6, so you could say -6, is going to equal a -1. So that means that nitrogen would have to be a +5 in order for it to be equal to -1. And so this is the one that has that element that has a +5 oxidation. And again, I'll help you with any of the other ones if you need me to. Just make sure you make yourself a note. Okay, number 2 says, which of the following compounds includes an element that has the same oxidation number as the chlorine in sodium chlorate? So again, they're going to make you do a bunch of work before you can even start to do this problem, and then you're going to have to do process of elimination. So again, these are going to sometimes turn out to be some longer problems, but they're worth the time because as long as you're patient and you know your rules, you should be able to do them. So this is going to be NaClO3, and that is a neutral compound. So since it's neutral, we know that it's going to add up to equal 0. Okay, we look for our rules. We're going to have alkali metals, alkaline earth metals, and aluminum get identified first. So sodium is going to have its normal charge of a +1. Then we look for hydrogen, no hydrogen. Then we look for oxygen, which we have. So this one's going to be a -2. Now, we don't care if chlorine's even on the list. It is on the list, but we're going to ignore it. We're going to have to calculate it. The last one always has to be calculated. So oxygen -2 times 3 is a -6. Again, I'm going to make a box here for chlorine because that's the one I don't know. And then 1 sodium is giving me a +1. So plus 1 plus something minus 6 equals 0. So chlorine has a positive 5 as its oxidation number. So you're trying to find one in your problem set that has a positive 5. Again, you are going to have to just go through and do the work on this. Our answer, we'll go through the one that is the correct answer just so you can see it, is C, which is AlNO32. Oh, NO33 actually. I can't even tell you how much this writing makes me want to cry. So that is going to be our right answer. So let's go through and identify the oxidation numbers. And if you notice on this one too, see how the answer was C again? They like to do that. If you have to use process of elimination, they're going to try to find ways to make it one of the later ones typically. So these ones have to add up to be 0 because that's the overall charge on this whole compound. We're going to look for alkali metal, alkaline earth metal, or aluminum. We have aluminum. So aluminum is going to have its normal charge for its oxidation number. So it'll be plus 3. Then we look for hydrogen. We don't have hydrogen. Then we look for oxygen. So oxygen is going to be a minus 2. So now we need to go through and total them all up. So aluminum has a plus 3. We don't know nitrogen. Put a box there. And then oxygen. I know each one's minus 2, and I have 9 oxygens. 3 in here, and then it's times 3. So that's going to be a negative 18. So for 3 plus something minus 18 equals 0, the something must be a positive 15. But the oxidation number of nitrogen is not a positive 15. It's a positive 15 for 3 of them. Okay, remember that transposes to this as well. So if 3 of them have a plus 15, that means 1 of them has a plus 5. So it has that same one as what we were looking for over here, right here. So therefore, that is our answer. Again, if you picked a different one, make yourself a little note to come and ask me, and I will help you with it. All right, so that was number 2. Number 3. Number 3 says oxygen takes the oxidation state minus 1 in hydrogen peroxide. The equation for the decomposition of hydrogen peroxide is below. Which of the following statements is true? Notice that if you read the answers, they're asking you what's being oxidized and what's being reduced. So you have to go through and figure out what the oxidation numbers of everything is in the compound. They've already told you, and this is where you can save yourself some work. They've already told you that the oxidation state for hydrogen in the hydrogen peroxide is a minus 1. So on the reactant side, you know that the hydrogen in hydrogen peroxide is a minus 1. Hold on. I'm losing my mind. It says the oxygen is a minus 1. You probably already caught that I was being stupid. So it says the oxygen is a minus 1. So since the oxygen is starting with a minus 1, let's look at what oxygen is on the product side. So on the reactant side, oxygen is minus 1. On the product side, it's O2. O2 is a neutral atom, so therefore it is 0. So for this thing to go from a minus 1 to 0, it must have lost electrons. My gosh, that was so slow. So it must have lost electrons because it's becoming less negative. And so therefore, remember, Leo the lion goes grr, losing electrons is oxidation. So you know that the oxygen is being oxidized. Okay, so you can only pick one that says oxygen is being oxidized. So that takes A out of it, that takes D out of it, and that takes E out of it. So that leaves us with B and C. Now we need to check the other ones. So if oxygen is a minus 1, if you do your oxidation numbers, hydrogen has to be a plus 1 on the reactant side. And then on the product side, if you go through the H2O, you're going to find that hydrogen becomes a plus 1. So you might think to yourself, well, that's weird because that didn't change. And that's because hydrogen is not the one being reduced. If you look, you have another oxygen there. You have an oxygen in H2O as well. So the oxygen on the reactant side was minus 1. Not only did it become a 0 in one of the two, but it became a plus 1 in the other one. So you not only went from negative 1 to 0, but you also went from negative 1 to plus 1. So this one is being oxidized, and this one is being reduced, That means oxygen is both the oxidized substance and the reduced substance, which is totally possible, as you can see. So the answer is C. All right, number 4, I think I have that one. Hold on. There we go. All right, so for number 4, we've got this equation. It says, which of the following statements about the reaction given above is not true? So it's just asking us about different elements. If you notice, again, they're trying to take up your time. They've got chromium on there, they've got iodine on there, they've got hydrogen on there, they've got oxygen on there. So you're going to have to go through this problem one by one. We know that the answer is C, so let me just explain why it is C, and then we'll be able to better go through it. Now, notice that they love these, and see how here it says not true? Your brain does not want to answer a question that is not true. Okay, so you're going to always be looking for the right one, and that's why they're trying to get you. Okay, you're going to go through and you're going to do chromium first, and you're going to see that chromium does go from a +6 to a +3, and a lot of people are going to circle that as the answer because your brain just doesn't want to accept not true. Okay, so we want the one that is not true. And if you take a look at hydrogen, you have hydrogen here, which has a +1. Okay, remember that coefficient doesn't make any difference at all. Okay, because it's just part of that balanced equation. And then you look at this hydrogen over here. Now, without even figuring out what that hydrogen is, which, by the way, it's a +1, but without figuring it out, I know it's not 0. The only way that hydrogen is 0 is if I have H2 here as a product, and I don't have H2 as a product. So, oops, I was pointing to the wrong 0. This is 0. So the only way I'm going to end up with that 0 there is to have H2 as a product, and we clearly don't. All right, moving on to number 5, which I don't have. It says, in which of the following molecules does hydrogen have an oxidation state of -1? You can eliminate E right off the bat because E is neutral atom, so even though it's diatomic, it's a neutral atom, so it has to be 0. But again, all the other ones, you get to go through process of elimination. Notice, again, the right answer is C. It's not A and it's not B. They like to not go to the beginning of it with these problems that require work. So our rules state find alkaline metal, alkaline earth metal, or aluminum. So we have an alkaline earth metal. So this one's going to be a +2 as its oxidation state. I know these are going to add up to be 0. If this is a +2, then inside this box must be a -2 to equal 0. And if 2 of them are -2, then that means one of them is going to be a -1. So this hydrogen has that -1 that they were looking for. All right, number 6. When solid copper shavings are placed into a solution of hydrochloric or nitric acid, Cu plus 2 ions appear and NO gas is bubbled. Which of the following has occurred? So they're giving you part of a reaction. They don't tell you everything, but it's fine because we don't need a balanced equation. We just need to know elements. So they're telling you that neutral copper is reacting with nitric acid. Again, I'm not even going to balance this equation because those balancings don't change the oxidation numbers. And it's going to make, it told you, copper ion. And then it also told you it makes nitrogen monoxide. By the way, you know this equation, so you could have predicted the whole thing if you wanted to. And it wanted to know which of the following are true. So they're going to ask you what's been oxidized, what's been reduced. I would always start with something simple, you know, like you've got this copper here. Copper is a 0 as a neutral atom. And over here, it's just an ion, so its charge is its oxidation number. Makes it really, really easy to look at. So it's going from a 0 to a +2, means it's becoming less negative, so it must have lost electrons. Okay, if it lost electrons, then it is being oxidized. Okay, so we look through and we see that C says that copper has been oxidized, and then it says by NO3 minus. Now, there's an option above it that says copper has been oxidized by H+. So clearly something in this compound is doing the oxidation. So what you want to do next is look and see whether or not hydrogen's oxidation number is changing which you see hydrogen here. We don't even see it over here, so it must not be changing, or else it would be part of that problem already. So something in here must be changing, which is why it's being oxidized by that nitrate, okay, more specifically. All right, number 7 and 8 I actually have. So number 7, again, it's just a matter of looking at what you've got. We're going to go right to the right answer, and if you pick something wrong and you need to check with me, you're welcome to email me, save it, and ask me on Monday. But this is the right answer, and they said pick the true statement. So if you go to sulfur, right here, sulfur has a -2. Remember, the 3 makes no difference. And then here, sulfur is 0. So if it's going from -2 to 0, it's lost electrons, so it is being oxidized. It doesn't look like any other option says oxidized. You know that it was being oxidized by this compound. Specifically, it was the chromium in this compound, because if you did out their oxidation numbers, you'd see that chromium, I believe here it'll be a +6, and then over here it's a +3. So that's the substance that's doing it, but it belongs to this polyatomic, so they say that it's that whole thing. Number 8, what's the reducing agent? Remember, as soon as you see reducing agent, you have to think oxidized. Okay, that's what you're looking for, is what's been oxidized. So you want the one that's lost electrons. As I told you at the beginning, the correct answer is S2. Okay, actually, is this the same equation as before? Almost. So this one goes from a -2 to 0. Okay, that's losing electrons. So that is your correct answer. All right, number 9. Little big, huge reaction. And our favorite question, choose the true statement, which means you are going to have to figure out all sorts of things. The answer was C. It says H2O2 behaves as a reducing agent. I would write next to that answer, when you were working with it, immediately remind yourself that means you're looking at what is actually oxidized. So if you go through and do your charges, you will see that the oxygen goes from a -1 in H2O2 to a 0 in the O2. Now there's lots of places where there's oxygen on the product side. In 2 of them it doesn't change. In 1 of them it does. Actually, it changes in a couple of them, but specifically in terms of the oxidation, okay, you can see it goes from a -1 to a 0. So it's the one that is being oxidized and hence is the reducing agent. All right, number 10, choose the correct statement from the following list. So they're asking us again. Oh, one thing on this one, you may have been confused when it said at the cathode on E, which was the correct answer. You'll learn about what an anode and a cathode is really soon, but it doesn't change your answer. Again, you want to identify your oxidation numbers, and when you do, you'll see that Br on the reactant side has a +5, and it becomes Br on the product side at a 0, neutral Br2. So that has to be gaining electrons to go from a +5 to a 0, so it's the one being reduced. Okay. Again, any issues on these, go ahead and mark them. We'll talk about them on Monday in class. Include them in your email when you email me, so that I know which ones I specifically need to make sure that we address. And like I told you with your notes, the backside of your notes is on balancing redox reactions, and we'll get into that, okay, this week. But you really need to have a good grasp of your oxidation numbers as well. All right, so email me, let me know anything that you need help with. Hasta la vista.